Hello students. In the previous video, we discussed on the two types of solid, that is crystalline and amorphous. In this video, we are going to discuss the classification of crystalline solids. On the basis of constituent particles, the solids, that is crystalline solids, are further classified. Like, if the constituent particles are the molecules, then it is called as molecular solids. And if the molecules, we can say that the molecule may be non-polar, polar or hydrogen bonded. So the molecular solids can be further classified into three types. And if the constituent particles are ions, then the solids are called as ionic solids. And in the case of metallic solids, the particles are the positive ions in a sea of delocalized electron, which we will discuss it. And if the particles are atoms and they are held together by covalent bonds, then it is called as covalent solids. So let us discuss this in detail, its properties and examples. So let us classify the crystalline solids. As we have discussed that it is based on the type of constituent particles. It is classified into four categories, that is molecular solids, ionic solids, metallic solids and covalent solids. Let us discuss the first one, that is molecular solids. As we have discussed, the molecular solids, the constituent particles are actually molecules. So these molecules may be non-polar, polar or hydrogen bonded molecules. So depending upon these, the molecular solids are further classified as non-polar molecular solids. As we discussed in plus 1, what are non-polar molecules? If you remember, we have discussed these points, the type of molecule, non-polar molecules. Let us take one example, that is example of hydrogen we are taking here. Hydrogen is a non-polar molecule. So two molecules of hydrogen are taken and a bonding attractive force found between these two, that is a weak attractive force, which is called as dispersion force or London force. This actually we have discussed last year. A temporary dipoles is formed and the force, the attractive force between them is actually called as dispersion force or the London force. These solids are usually soft and they are insulated. That means they are non-conductors of electricity. They usually have low melting point and are usually in the liquid or in the gaseous state at room temperature. The examples are hydrogen, chlorine, iodine, argon, etc. So these are the non-polar molecules. So these solids are actually called as non-polar solids. Next is polar molecular solids. Polar means the molecules which have two poles. As we discussed last year, it have two poles. Example, we are taking HCl. In HCl, the two poles are there because there is electronegative differences between the two atoms, that is Cl and H. So it develop a partial positive charge here and Cl develop a partial negative charge, and if two molecules are taken, there is an attractive force between them, and this attractive force are called as dipole-dipole interaction. Why? Because This is a dipole, this is a dipole, and a force of attraction between the two dipoles are called as dipole-dipole interaction. Here the constituent particles are polar molecules, and the force of interaction between them is called a dipole-dipole interaction. They are usually soft, non-conductors of electricity, therefore insulator. They have low melting point, and usually they are liquid or gas at room temperature and pressure. So their examples are HCl, SO2, etc. So that is the polar molecular solids. Next is hydrogen bonded molecules. We discussed last year hydrogen bond that is found between hydrogen and oxygen, or hydrogen and fluorine, or hydrogen and nitrogen. So as we have discussed the structure of ice last year, ice is a solid, and there is a formation of hydrogen bond between the molecules. You can see here, this is one water molecule, this is another water molecule. There is a formation of hydrogen bond which is represented by dotted lines. So here the constituent particles are hydrogen bonded molecules. The force of interaction between them is hydrogen bonding. These are usually hard insulator and have low melting point. Usually they are volatile liquids or solids. The best example for this is ice. So thus we have discussed three type of molecular solids. Now let us discuss the next second category, that is ionic solids. Ionic solids, in this the constituent particles are actually ions. Therefore it is called as ionic solids. The very best example, that is NaCl. NaCl is made up of two ions, that is Na plus and Cl minus, and there is a force of attraction between the two ions, that is electrostatic force of attraction, because opposite charges always attract each other. So this force is actually electrostatic force of attraction, or we can say strong Coulombic forces are there. Here the ions are the constituent particles, and in such solids are formed by three-dimensional arrangement of cations and anions bound by a strong Coulombic force. You can see the three-dimensional arrangement of the cations and anions, which is shown in two different colors balls, that is Na plus and Cl minus. And we know that common salt, which is an ionic solid, act as an insulator in a solid state, but they are even conductors in the aqueous or molten state. Why? Because in the solid state they are arranged in the three-dimensional structure which is shown here, but in the aqueous condition they get ionized, and the ions, now it is free. So in the molten state or in the dissolved state, the ions are free to move about, and therefore they conduct electricity. They are usually hard and brittle and have high melting point. The further examples are MgO, ZnS, CaF2. So this is about ionic solids. In metallic solids, metal atoms like copper, iron, silver and magnesium lose their valence electron to the crystal as whole. These solids are merely a collection of positive ions surrounded by a sea of electrons. Hence, the constituent particles in the metallic solids are positive ions in a sea of delocalized electrons. From this, we conclude that metallic solids, the constituent particles, are the positive ions in a sea of delocalized electrons. The bonding in between them is called as metallic bonding. They are quite hard but malleable and ductile. Because of the free electrons, they are very good conductors of heat and electricity. They have high melting point. So the examples are all the metals. The next one is covalent or network solids. We are quite familiar with the structure of diamond and graphite. The three-dimensional structure which is shown here. Here the constituent particles are the atoms. In the diamond and graphite, carbon are the constituent particles, carbon atoms. And there is a strong covalent between these particles. And we already discussed the structure for these two. The diamond is hard, quite hard, and the graphite is soft, and they have very high melting point. So this is all we have discussed about the four types of crystalline solids, that is molecular solids, ionic solid, metallic solid, and covalent solid. This is classified on the basis of their constituent particles, and we discussed the force of interaction between the particles, their general properties, and examples of each. So in this way we have finished the classification of crystalline solid. In the next video we'll be discussing the more details about the crystalline solids. So thank you everyone.